Right. So let's get into it. Today is um, technically the first day of stepping into the world of data analysis and data science. And like I like to always say, in my opinion, the first thing that you should learn when stepping into data science and analytics, in my opinion, is SQL. SQL because it actually helps you to have this appreciation for data from the point of view of analysis and all of that. That's one. Databases is where data lives, and as such you get to, like, before you start doing the modeling, the analysis, the hypothesis testing, the machine learning and stuff like that, you get to actually understand how to query data, how to work with data before you now add any layer of complexity to it. That's one. Second thing is, if the second reason why I feel like um, the first thing you should learn is SQL is because it has very very nice syntax. So if this is your first step into programming, even though SQL is not like programming as such, it gives you this very nice way of sharpening your critical thinking skills and how to um, you know how to think in code, in query. So that's what we are going to be doing for the first few sessions. Having said that, the goal of this lesson is to understand how to create databases, how to populate databases, how to with tables, how to populate tables with columns, records, and how to just do all of these things in a how to administer a database basically. And why do we need to understand how to do this? The reason why we need to know how to create databases, populate it, is just so that we can understand the inner workings of the database. As a data analyst or a data scientist, you won't, or let me say, you rarely have to create databases. But in my experience, nobody is really going to trust you to query their database and all of that if they do not believe that you understand how the database works at the fundamental level. So what we want to do today is we want to understand how databases are created. Then we are going to explain in great detail the inner workings of a database, like how this thing works, everything that a data scientist or a data analyst is expected to know. So now this is Workbench. The my IDE of choice is Workbench. IDE means Integrated Development Environment, and that is where we write code. I'm writing my code against the same MySQL server. So if you are on other IDEs like VS Code, for example, Notepad, any IDE, all you have to do is just make sure that you keep the same convention, the writing convention, and you are going to get the same result. But if you are on Workbench, like I am right now, this is the query area. This is where we write query. Around this place here is the action output where we get the result of our actions. Just going to clear this off so that we have a clean action output. Then we have the schema area where we have our databases that has already been created. Then if I should click on, let's see, this is a practice database, then tables, and I click on one of the tables. So I get this information area where I see more information about the column and the table that I've clicked on. Now, let us actually get into what we want to do. So, to write a query, we can do two things. First thing is we can say this is a comment. Now, what I'm putting this out very early because it is a very good thing to understand that you can comment on your code, and the comment that you put on a query is just your way of telling SQL that okay, don't touch this line. This is just for my own consumption or for human consumption. Like this is natural language. This is just pure English. So I'm just saying here that uh, if I come back, I want my future self to be able to understand in plain natural language what I'm trying to do, like the query that I'm trying to write. So it's important because a good code, one of the characteristics of a good code or a good query is readability. You know, when you come to it, you want to be able to, when you come back to it in the future, you want to be able to make it easy for your future self to understand it. Or if you are working as part of a team, you want to make life easy for your teammates. So then you can now like write your code here, whatever that is. And this is a single line comment. Actually, this is a single line, it's a single line comment. So to do multi-line comment, we do something like this. Excuse me, sorry. Yeah. So if we want to do multi-line comment, we can go. This is a multi-line comment, and it runs, it spans multiple lines. Great. So this is a multi-line comment. So all of this, um, whether single line or multi-line, MySQL is going to ignore it. So that is the way it is. Now I'm just going to edit this into the section that we are in. So I'm going to say how to create database, how to create databases, or let's say what are databases and how do we create them. That's better. What are databases and how do we create them? So now a database, how do we create them? A database is um, just within the context of what we are learning, right? Within the context of uh, data analysis and data science with respect to MySQL, a database is a collection of related tables. Database is a collection of related tables. And whenever we say databases, we are really talking about relational database. So basically, a relational database is a collection of what? Related tables. And basically, a table is just a collection of rows of information presented in rows and columns. Now, some people would say features and attributes, records and attributes presented in rows. So there's a records and columns. You can call that one features. Exactly. So that's basically what a database is. So every business out there, every technology out there, every software out there, majority of softwares, at least ones that track activities on their system, they're going to have a database where they keep all of the user activities, right? And they do so usually in a relational database. And one of the things that relational databases excel at is helping us to ensure data integrity, right? Making sure that we are not carrying redundant data. So it links the information in the database together in a very nice way, uh, so much that we don't have to repeat some things. We keep our database very, very durable, with integrity, and with non it is not redundant. You are going to understand what I mean by that shortly. So let's you are going to understand it better shortly. So let's say we have okay, how do we actually create a database? Let's start with that. So creating database. Creating a database. So to create a database, like I said at the beginning of the lecture, uh, MySQL, which is an RDBMS. What is an RDBMS? A relational database management system, and it is a system or a tool that we can use to actually model the activities of a relational database. Like we can use it to actually create databases, manipulate databases, and all of that stuff. And there are a few of them out there. There is the MySQL that we are using currently. There is Microsoft SQL Server. There is PostgreSQL. There's IBM DB2 and a few of them. But anyone that you learn is fine, because SQL is pretty like the same thing across board, and there's just going to be like tiny little syntax variation from one to another. So how do we create a database? So for this class, for this lecture, we are going to be creating a database of let's say a school, right? So we're going to have create, and this is how you do it, database, let's say Harvard, and we are going to end it with a semicolon. Now I need to explain an important concept here, and that concept is that whenever you write a query, you must end it with a semicolon. You can think of semicolon as like the full stop in our natural language. So here I said a relational database is a collection of related tables. Then I added full stop here, meaning that this is the end of like an idea, of a thought, of a sentence, right? So the same thing. If I like do not put it here, this sentence will probably still make meaning, but I'm actually just going to like model everything up to this line. So it's going to be something like a relational database, a collection of related tables, a table. So you don't want that. You want something like a relational database, a collection of related tables. Full stop, right? That's one line of thought. Then a table is that's another line of thought. So you can think of that as the way semicolon works. So the way semicolon works is it gives you this vibe of okay, this is the end of one thought. So create database Harvard full stop. Now, if you don't have this semicolon here, will this still work? Yes, it will work, but the next query is not going to work. The next query is not going to work because it's going to be thinking of the next query as being part of this one that you did not end. So that's just the idea behind. But good practice, best practices, whenever you have create database, end it end it with or it does not have to do with create database alone. Whenever you have any query and you've written your whole idea, what you want to do is end it with a semicolon. Now what we want to do is we are going to use this to execute this line here, this lightning sign here. If you are in MySQL workbench, so I'm going to use this line here. If you are on VS Code and you are using something like MySQL tools, SQL tools, you should highlight this code that you've written, then press Control EE, Control and E twice, Control EE, that will do it. So In my case, I'm just going to run this like this. So I get this output here that says create database Harvard. Success means this green check means success. Everything went like fine. Then you're going to notice that other databases are listed here, but we do not have Harvard here yet. So what we are going to do is we are going to just say refresh. There is going to be a refresh button here, and it's going to pick it up. That is in the event that you do not have, you do not see it here already. So here you can see that you have Harvard here. So if you're on other IDs like VS Code, you probably do not need to do this. It's going to pick it up the moment you run this create database Harvard, and you're going to see it here. So great. Great. The next thing we want to do is how do we actually now populate this particular database? Because if you check within this database, you're going to see that we do not have any tables within it. But if you check through the previous databases that we already have, you're going to see that the tables, contain stuff and all of that. And the reason why our, our table in this Harvard database is empty is because we do not have, for now, we do not have any table yet. We haven't created any table. So the next thing for us to do is to create a table. But before we can do that, something that is extremely important is now, whenever we want to start working on a database, we have to switch our context to that database. Like that is switch our attention to that particular database. And the reason why this is extremely important is because um your RDBMS, your whatever thing you are using to manage your database, has the ability to handle multiple databases at once, but it cannot like work on multiple databases the same time, right? So what you want to do is you want to switch. For example, currently the attention of my system is on this Northwind database. So I want to switch it to this other database that I've just created. So what I'm going to do is I'm going to say use. I'm going to add a comment. I'm going to say switch attention to the newly created database, that is, i.e., Harvard database. So how do we do that? We are going to say use, very easy. We are going to say use Harvard, then run this. Use Harvard, then run this. I'm going to like just run this. And you're going to see that use Harvard went in successfully. We have this green check and it is now bold. Not when it's not bold anymore. Great. So that's how you switch. If I want to switch back to Northwind, I can do that. Just say use Northwind, then run this again. Northwind is bold now. Attention is now on Northwind. Then if I want it to go back to Harvard, I'm going to go Harvard like this and run this. And we are now on Harvard. So we can now start creating our table. This is important because if we do not switch to our database of interest, every activity that we do is going to like be the change is going to be happening inside this Northwind database, which is not what we want. So we want it to actually be happening inside Harvard. So next thing to do is to create tables within the database. So we're going to create tables. And how do we do that? How do we create tables? The way to create tables is to come to um, this page here, and within, in our mind, we have to firstly like understand the kind of tables that we want to, the kind of structure that I want this database to have. So in my head, I'm already thinking Let me set, if we say we want to have a strategy, let's have a strategy. You don't have to, it's just to like bring clarity to what we are doing. Say strategy. Our strategy is going to be to have a few tables. We're going to have staff table, or let's say lecturers table, lecturers, two students, and three probably have courses. Right. So these are the three tables that we are going to be creating. So the way it works is we are going to have a lecturer's um, um, table. We are going to have a students table, and we're going to have courses table. And students are going to be assigned to courses. Lecturers also are going to be assigned to take courses. So at the end of the day, students is going to point to courses. Lecturers are also going to be pointing to courses. So how does that work? We can come here and say the first table that we're going to be creating. Let's start, since students is going to be pointing to courses, lecturers are also going to be pointing to courses. Then the first, and courses not pointing to anything. The first table we should create is courses. So we're going to say we're going to say create. Let me add a comment here. Say create table courses. So don't forget, this is just a comment. To actually create it, we are going to say create table, and the table name is going to be courses, and in bracket I'm going to come here and do this. I like to always do this at the beginning so that I don't forget to add it. So one create table courses, and within the table, whenever we structure it like this, within the table we are going to define the kind of columns and data types and the behaviors relationship that we want to happen within the table. So to start with, we are going to start by adding the primary key, the identifier, right? So we're going to have course ID, and it is going to be integer like this. So what this means is we are going to have some, our first column in the courses table is going to be course ID, which is going to have some integer values, course ID 1, 2, 3, like that. Then we can move on and say name, or let's say course name, and that's going to be varchar. So what does varchar mean? Let me add this first, 30. So what does varchar mean? Varchar means variable characters. So it means that for course ID we said integer. So it means that whenever somebody is adding, they are entering values into that course ID column, it has to be integers, positive or negative whole numbers, which in this case we are expected to be positive whole numbers. Then course name is varchar. So varchar meaning you can enter anything. Your course name could be anything. So letters, alphabets, numbers, anything. So that's basically what varchar means. And usually varchar is way more efficient. You could literally like write text, but varchar is very very efficient, and you're going to see it if a whole lot of time. It's like the industry standard. So whenever you want to add text, probably should use varchar. Then you can, in this case we added just one constraint and one data type. You can add multiple stuff. So another thing that we can add is not null. So what we are saying at this point is, well, we want course name to be varchar, that is variable characters, words, anything that you want to add, but it should not be more than 30 characters. Your course name should be within 30 characters. Any course name that goes above 30 characters is not going to be accepted. Then not null is you cannot not I hope that's correct English. You have to fill up this course name. Course name cannot be empty. That's what this means. So we can go to the next line and add let's say units, and that also is going to be integer. It's going to be not null. Perfect. Then these three things are fine, I guess. Now the next thing we want to do is we want to add some other behavioral characteristics for this course ID. So we've already created all of this structure, but let's add something in terms of behavior. So one thing that we're going to add is a constraint called primary key. So primary key is a unique identifier. So we want to make this course ID a unique identifier. That is, whenever anybody wants to access any row, any course, any particular course, they can access it by an identifier. And you can think of it as the same reason why whenever you sign up on every social media, the first thing they give you is a username. You have a name that is yours already, but that name is not unique to you. Let's say your name is John Maxwell. You are not the only John Maxwell in the world. That combination of name is not unique to you, and we need something that can uniquely identify every record in a database, so that anytime we want to particularly just address that record, we have something to point to that record. And that is what primary key is. So what we are going to do is just say primary key, excuse me, course ID, like this. So that is perfect. So we've defined the schema. So what we've done here is schema definition. And what's a schema? A schema is the blueprint, the architecture of a table, of a database table. So a schema is the architecture of a database table. So we are going to run this and see. So if we execute this schema, it creates a table for us. So let's run that. It went through perfectly, but for now we're not seeing a table here. So what we need to do is refresh this. Now we are seeing a table here, courses. So I click on this now. We have course ID, course name, and units. And they have the exact constraints that we've given to them: integer, primary key, varchar, 30, and int. So but the table is empty for now. So let's move on. Let's create our second table, which is going to be create table lecturers. Lecturers. So we can come here and say create the same flow table, lecturers, and we open close this like this. We go the way down. Then we can start by getting their first name. Yeah, like space is not a good thing in programming generally. So if you want to like add space to anything, it's preferable to just use underscore. So first name, you might have guessed it, it's going to be varchar 30, not null. Last name, varchar 30 also. It doesn't have to be 30, it could be anything, 35. It's just the space that you're allocating, not null also. All right. So, but we should add, the first thing we should add really is lecturer ID. It's lecturer ID. And that is going to be int, comma, like this. Then we should add gender. And for gender, we could do varchar like this, but we'll have a problem. The reason why we're going to have a problem is, sorry, varchar 20. We could do this, but the reason why this is going to be a problem is because voucher could take anything. It's going to allow you passing anything, and we want gender to just be something like probably male, female, others. So if we just do voucher 20 like this, it's going to accept anything. So if somebody should come here and say my gender is Manchester United, it's still going to accept it, which is not a behavior that we want for this gender column. So we can use something called enum, and in this enum we can pass. We use enum for doing something called close bounded categorical variables. So we want to pass in a categorical variable space that people can actually choose from. So we say, and we force them to choose from there. So we say male like this, comma female. Then we can say others. Then we can close this, right? And another thing that we can do is we can set default so that in the event that somebody does not provide their they do not provide their gender, we can default it to others. Or the best thing would be to say, let's add one more and say we won't say. So whenever somebody skips this column, just fill it up with won't say, right? Like it can either be male, female, others won't say. Then if somebody choose to skip this column, just pass in won't say there. So that is what default does. It helps us to fill in some default value into any place that somebody skips. So instead of holding them down and saying, "Oh, you cannot go," which is what not null does. So we use default and say this. And another thing that is important to reiterate is what enum does. Enum make sure that you are only passing one of these values here, right? Then the next thing I want to do is we want to pass in their date of birth, or let's say birth date, and that is going to be date. Then we say not null. So that is perfect. Then the next thing we need to add is actually we need to assign them a course, right? Like they have to be assigned a course. So that means we are going to assign them with a course ID. So we're going to come and say course ID, and that's going to be integer that cannot be null also. Then we can come down here and declare our behavioral flow. So first thing is that lecturer ID has to be a primary key. We say lecturer ID, I'm sorry, we say primary key, lecturer ID. Then the second thing that we need to do is link up our foreign key. And what's a foreign key? A foreign key is the representation of primary key in another table. This course ID here is representing this course table, this course ID particularly that is inside this course table. So we want to link these two tables together. That's the reason why we have this course ID here, so that we can know which lecturer handles which course. So the representation of course ID, this course ID, in another table, lecturers, which is not his original table, that is what we call foreign key. So that is the representation of a primary key in another table. So we say foreign key. You can just think of it as a mother-child relationship, just like a PTA meeting. So if you have a parents-teachers meeting, you go to that parents teachers meeting to represent your child. So that's kind of like the foreign key thing that we are seeing. So it's a foreign key. I'm sorry, we are missing a comma here. So it's a foreign key, lecturer ID, lecturer, I'm sorry, course ID, sorry, foreign key, course ID, references, course, course ID. So basically, what does this mean? This means that the foreign key course ID, which is this one that we are seeing right here, right now, is pointing to or pointing at the course ID that is inside course table. Just it's a very simple stuff. Just like normal English. Foreign key course ID reference is course ID. That is foreign key course ID. This one that is currently inside our lecturer's table is referencing the course ID that is inside the course table. So once that is done, we can just run this. So we have an error. Great. That is our first error for the day, and it is going to like point us into how to actually debug error. So what you want to do is you want to come to the error message, and I usually tell people uh, whenever you are learning to program, to code, to write query and stuff, the skill that you actually want to develop a lot is how to debug, how to read errors and fix it. So do not debug blindly. Do not assume things. Just read the error message. It says fail to open the reference table course. It's telling you that I cannot open the reference table course, and it's for like different reasons. The most obvious one will be probably it cannot find anything named course. So let's go and check what we named that. So there's no such thing named course. It's actually named courses. So we need to come to this place and we are calling it course here. So that's the reason we had S here. So it's not going to fail to open it anymore. So we can, okay, we are perfect. So we can just run this now and see whether or not we are good. Perfect, we are good now. So it fixed that. So instead of me doing a lot of try and error, is easy. And you might want to be your brain might want to trick you into thinking, okay, what could be wrong? Let me try and tweak this. Just read the error message. It's never that serious. Just read the error message. You're going to see exactly what the issue is. Just fix that and you are good. So we've done that. If we refresh this, we see lecturer's table has been created with everything that we want it to have. So let's create our last table, and the last table is going to be students table. So we say create. Let's add the comment here. We're going to say create table students, and we are going to go create table students, and it's going to be like this. So we'll go students name. Let's just take their, okay, let's start with student ID, the primary key. I like to tap this just to create that visual uh, cohesion. So student ID, then full name. Let's just take their full name. And their full name is going to be Varchar 40, not now. Then we can say gender. So we can go in now. But in this case, I'm just going to do male, female to save time. Male, female. Default it. Don't let us default that. Let's just do not know. So that they are forced to give us something. Then we go birth date, and that's going to be date, right? And that also is not null. Then we can link them up to a course ID. That's also going to be integer and not null. Then we'll create our primary key. Our primary key is going to be, we are missing a comma here. So our primary key is going to be the primary key student ID. Then our foreign key, we are missing a comma here again. Foreign key course ID, just like we did earlier. It's going to references courses course ID. Perfect. So that should fix it. Then we can run this. So then we see whether we have errors or not. We don't. So table students has been created. So if we run this, we see that we've created our three tables: courses, lecturers, students. They are all connected, they are all created and all connected. So the next thing for us to do would be to come to this place and see how to. There are a lot of other constraints that you can go through. I'm going to link a resource for every single constraint out there, and I'm going to add an assignment here so that, or an exercise that you can work on, or that you should work on, and it's going to like expose you to much more constraints. There's check, there's a lot of other things that you can work on. There is a lot. We've seen default, there's date time, there is all of those stuff. So you just need, they are implemented the same way, but they just do different things. There is auto increment, stuff like that. But by the time you work on all of those, you're going to get an idea of how each one of them works. So we've created the tables and we've defined, the schema, the architecture, the structure of the table. But what we haven't done is we haven't populated those tables with data. So for example, if I should click on this one here, these courses, this small box in front of courses, you're going to see that it returns an empty result for me. There is nothing inside it, although we have the table name and the column names. So, but that's not, the same is not true for example, if I do it for Northwind, the tables inside Northwind. So let's try and get one of the tables inside Northwind. And don't forget that Northwind has data already. So if I should click on this, I get this information, a lot of this information. So we want to do the same where we actually fill up each of these tables that we've created. We want to fill it up with data. So let's try and just fill it up with data. So we're going to say populating tables with data set. So the first thing that we want to do is we want to go. So whenever you want to do that, you use the insert into. Say insert into. Insert into. So the first one is we have our courses table and it has three things: course ID, course name, and unit. So we say insert into courses. Then we can open our bracket. In some cases, it's probably going to be insert into table courses like this. Then we can add the names of the columns that we want to add. So we have course ID, course name, unit. So we can go course ID, course name, we can have units. Then next thing is going to be values. values. Okay, I think it has to be inserted into courses. Then values, we can open that. Then we can type in each of the values. So we can go like course ID one, course name is, let's say, intro to DSA, unit is 3, can go course ID 2, excuse me, and the title of that is going to be algorithms, then maybe 2 units. Then we can go course ID 3, title of that is going to be maybe linear algebra, the unit of that is going to be 1, I guess. Then the last one, let's just ask for the last one, and it's going to be calculus, and the unit of that is maybe 4, and that is the whole thing. I'm missing a comma here. So if we highlight this and run it, or you don't have to highlight really since we've not been doing that, but if you're on other IDEs, you might probably need to highlight. So that has run, that's added it. So I should refresh it, then come to courses and do what we did earlier. Click on this small box. You can see that we now have those values: course ID 1, intro to DSA; course ID 2, algorithms; course ID 3, linear algebra; 4, calculus. So there's data in our table now, and which by extension means there is data in our database. So let's create for the lecturer's table. So here's the thing now. Here's something interesting. If I should try and rerun this again, we're going to get an error. Don't let me highlight. Let me just run this. And the reason why, look at what the error says. It says duplicate entry 1 for key courses does primary, meaning that it failed at the very first instance, right? What does that mean? It's trying to tell you that you are trying to duplicate a primary key. Don't forget that a primary key has to be unique. You can't have a primary key that has the same thing. So, for example, so if I should come here and say 8, let me give this one 8 and rerun this, we are going to still have an error, but it's not going to be duplicate entry 1. It's probably going to be duplicate entry 2 because, well, we are not repeating 1 now, we've changed it to 8. So, okay, I don't need to highlight again. So, let's come here. So you see what the error is now? It says duplicate entry 2. That is, you've created 2 before and you're trying to like do that again. So basically that's what it is. So if I want to add more data set, I have to actually add new primary keys, right? So I'm going to come here and we insert values into, let me say insert into, which one is that? I think the next one is for lecturers. So I can say insert into lecturers, and you don't necessarily have to list this. What I mean is you don't necessarily have to like list out all of these columns like we just did, right? So you can just have that place empty, so you don't have to list all of this. But I found that listing makes it easy for me to just know what I'm filling in. But that's perfect. In this case, for the sake of learning, we are not going to list it just so that you see that it works. So lecturer ID, first name, last name, gender, birth date. So we're gonna come here and say values, and we go to the next line, and we go lecturer ID is going to be 1. Their first name is going to be John. The last name is going to be maybe week. Then let's check. Can you see what I was talking about earlier? Gender, we do male, birth date, course ID. So gender, we go, let's just go M alone. We don't add male. You're going to see that throws an error. Then birth date, you're going to notice that all of my vouchers are in quotes. That's important. And all of the integers, they are not in quotes. Then the date also has to be in quotes. So this is going to be something like 2000. Sorry, yeah, 2000 year first, then month, maybe 7, maybe 12, something like that. Then the course that they are associated with course 2 or 3. Then I can comma this, then copy this a few times, paste it here, paste it. Then we can just edit this. So I'm gonna go 2, this lecturer 2, lecturer 3, lecturer 4. So we can see this is Lucas Scott. Mail also. This year does not exist. Year 20,000. That's a lot. So this could be like 2003, I guess. Then the next lecture is, let's go for someone. Okay, let me go full male here. Can go female here. Female here. Then this female is probably going to be someone like Rachel Zane. Then this is going to be 2005, I guess. Then this person is teaching course 1. This one is course 3. So we have lecturer 4. Maybe that is Steph Curry, I guess. Then 1999. Then Steph teaches course. Let's say Steph teaches course 7. I just want to like show you some things as in like throw errors. So let's run this. First, we are going to have an error, and we'll debug it together. But I don't want you to, start having errors when you are working on your own and you're like, well, everything worked perfectly in class. So first thing is, it says data truncated for column gender at row 1. What does that mean? We stopped executing for this gender column at row 1. Why is that? Well, the reason is because M is not part of what we ask this thing to take by default. So we say it has to be one of these things here. So let's give it, is either we give it male or we give it others, or female, or the other stuff there. So I say others like this, um, and run it. So we don't need to highlight. So let me just, I keep doing that. So let me just, so we have another error. It says data truncated for column gender at row 4. Well, row 4 also there's no such thing as M. So there's row female here. Then again, we can run this. You have another error. It says cannot add or update a child row. A foreign key constraint has failed. What is that trying to tell us? It's trying to tell us that this particular thing here, I told you, the foreign key is the representation of primary key in another table. So basically, what that means is you are here for a PTA meeting and you don't have a child in this school. That's basically what it means. It says there is no such course as course 7. There's no course 7. Courses are from 1, 2, 3, and 4. Course 1, course 2, course 3, course 4. So if you are saying you are teaching course 7, what course are you teaching? For example, John Wick teaches course 3. It means John Wick teaches linear algebra. Lucas Scott teaches introduction to data structures. Rachel Zane teaches linear algebra also. Steph, what course are you teaching? You're not teaching, there's no such thing as course 7. So we can come and say Steph teaches calculus. So we can now run this now and basically it should work. So everything works perfectly now. So I want to believe you saw how I was able to do the whole thing, like just add this one and that one. So that is that. For lecturers, we should try and do this. see Harvard and all. So another thing I would love to do is show you how the default values work. So all of these things work perfectly. So here, when we're creating the lecturers table, here we said, well, if there is a default, just add one say there. So let's create something like that. So I'm just going to copy this. Control C, paste it here just to show you on a fresh page. You could have done it anywhere. So here, I'm going to actually add lecturer ID, first name, last name, last name, then birth date. So obviously now I'm not adding gender. I like skipped gender. So I want to show you what's gonna happen. So if I should come here, lecturer ID in this case is gonna be 5. That's the next person. And let's say their name is Kyrie, I guess. Then we are not specifying their gender here, so we're just doing their birth date. So we can go for their birth date is going to be 1945. I don't know. To 12. Now, obviously, I'm not supplying gender here. So let's see what happens. Is it going to throw an error or is it going to run? So if it runs, what's it going to do? So it says unknown colon first name. I guess first name is first underscore name for lecturers. Yes, it's first underscore name, last underscore name. So I read this unknown column first name. The way I wrote first name is not the way it is in the table. So first underscore name, last underscore name. Let us run that. Another error unknown colon birth date. I guess birth date is birth underscore date. We'll run that also. It says field course ID doesn't have a default value, meaning that our course ID here, we didn't supply a value there and there's no default for it. So it means we have to come here and do course ID and supply course ID. Let's say Kyrie teaches algorithms 2. Then we'll run that. I want to believe you are seeing all of the changes I'm making. So we can now run that. So it works now, even though we didn't specify, we didn't give it gender, right? It works. So let's see what gender is going to give that person. I think we have this working already. So I can say Control A. I don't have to. Then run this. So now we have Kyrie. Can you say Kyrie Avin? And Kyrie's gender is won't say. And why does it have won't say? Even though we didn't specify anything, is because here we say whenever somebody does not specify their gender, just give it won't say. So that's how that works. Let's go to okay. Let's create another. Okay, you've seen that whenever we try to supply a gender that is not within the value, it is going to throw an error, and that is how enum. That is what enum. This enum here. That is what it allows us to do. So let's do for students, and that is we add students. We're going to insert values into students. So basically, I'm just gonna like to avoid typing a lot. I'm gonna copy this here, paste it here. It's easy if you've gotten the hang of it. It is really easy. Students, then yeah. So we we just edit the input here. So let's say the student name is John Legend. Let's see if the way this is structured. So student ID, their full name instead of first name, last name, their gender, birth date, course ID. So full name, So this is supposed to be within each other. John Legend, let's say Lucas Scott, Rachel Zane, Steph Curry. So maybe Steph London, yeah. I don't know. Then Rachel Taiwo or something. Just to change the names. Then Scott, Travis, and yeah, let's just keep the other things to the answer. We have gender. I want to check what other thing we have. Gender, birthday, course ID. I think everything is fine. Yeah? Gender, birthday. But there's going to be an error here, but I want us to run into the error without others because others is not part of the norm for students. So we can come here and run this. So it says data truncated for column gender at row one. That is, there's no such gender as others. So we can do female. Let's run that. So it worked. Our students table is populated now. So I can check this and we have all of the our information here. So basically, that is how you would create a database, populate it, and do all of this fun stuff. So I hope you understand it a bit. And the exercise that you're gonna do is exercise. It's going to be to create any database of your choice that has at least three tables and populate each of the tables, each tables with data. So that's the exercise. Do well to practice it, submit it. You only get better by practicing. Thank you, and see you in the next one.